Welcome everyone to this new episode of Polkadot SDK Unwind. It's the SDK Unwind here, tuning in from Berlin. Where are you guys tuning in from? Um, I apologies for a little bit of a tardy start. We have had some sort of issues with mics and audio. And anyways, how's it going, everyone? Super stoked to kick off this second episode, really episode number one, right? So uh, please feel free to say hi and let me who was there from the previous episode. I'm curious to hear who actually watched it and who participated. Real quick, what are we doing here? I'm well, first of all, my name is Sacha. I work at a company called Parity Technologies, and that's the company building Polkadot and the substrate library for building blockchains. So I work as a developer advocate at the company, and I'm on a mission to help developers build with these technologies and understand them. And hopefully some of you are new and can benefit from these streams where I really want to kind of take a step back and really provide a starting point for newcomers looking to build something in the Polkadot ecosystem. Um, so that's the little bit about what we're doing here today, right? So this is a new series that I started whereby the approach is kind of open format, right? It's I don't have a script, I don't have a set presentation. We're not going through a PowerPoint. We will just kind of take it as it goes, and in this first few episodes, what I really want to demonstrate and to be able to um, sort of ease our way into is what is this Polkadot SDK? What can we be doing with it? And what are some tips that I can share as we go along? And really, that's sort of the key point here, right? As we go along, you don't need to be following each and every episode, but really, this is a place for either developers that are already experienced with building stuff in the Polkadot ecosystem and might have things to share. And who knows? We could probably feature some of you guys one day on this series where you guys can come up and share a bunch of things. So that that you're building with, or that you or some tips that you want to share. So I'm really this is a place. This is like a this is a place to just hang out, right? Like so welcome, guys and gals. Where's everyone tuning in from right now? So actually a little bit of pressure's on me right now because last last episode was just streaming to Twitch. So right now we actually have audiences from Twitch, the Polkadot Dev Twitch, that is. We also have audiences from our Twitter, the Polkadot Devs Twitter, and our Parity Tech LinkedIn. So please engage, and those that are engaging, stay on topic. I know that there's a lot of trolls out there, a lot of people that probably aren't watching this type of content for anything other than putting some stuff that we don't want to hear about, like prices and dot prediction. We're not here to talk about that, right? We really are here to discover what it is we can be building in the Polkadot ecosystem. Again, this is really a great place for people that are starting out with what it is that you want to build, right? So whether you're beginning in your journey in Substrate, maybe you heard Substrate at a conference somewhere, maybe you're an Ethereum native and you're curious about Polkadot and what it is that you could be building in this ecosystem. In this very first episode, technically it's episode 1, we're gonna kind of keep going from where we left off. So I'll give sort of an overview as people tune in to the stream. of what our plan is today. So, but yeah, my name is Sacha. You can find me on Twitter. That's kind of where I keep people up to date with either stuff that I'm working on or stuff that I can that might be relevant for people in the developer community to learn about, and things that I find relevant to share. Uh, let me find you that the old ye old Twitter link. Uh, this whole like get used to start saying X. To be honest, I'll start saying X as a platform when the URL twitter.com just no longer works anymore. But for now, I think you guys can forgive me if I'm not technically correct on that front. Yeah. Oh yeah, how do I do this? Oh yeah, I'm gonna share this for you guys. Behind me is the Polkadot relay chain, by the way, as you can see. We've got blocks being produced. I wonder what's the public opinion on this diagram. I think it's a great kind of like graphic, and it's basically been used everywhere since the very beginning of Polkadot. Strangely enough, like there's not been like a sort of upgraded graphic of what's behind me here. And I wonder whether some people find it, really good. Some people might find it misleading. I had a chat with a colleague the other day who was saying, like, this graphic is really, really technically misleading because it doesn't really show much about parachains and the way that blocks are produced and stuff. Um, just sharing that with you guys. If there is any thoughts there, I'd be curious to check it out. Yeah, so yeah, you can find me on Twitter. So that's Sacha, Sacha. That's how you pronounce my name, and spelled differently. Je parle français. Yes, I'm French, and that's why. And literally, so it's SACHAL 2 underscores. And you can find a bunch of stuff that I kind of keep people up to date with there. Jumping into things, right? What are we doing today? So we'll be so from the last series from the last episode that we did, it occurred to me that I might have missed a lot of like basic sort of what are we doing when we're talking about like starting to build with the Polkadot SDK. And I kind of want to cover that. I kind of want to like get back into sort of what would be the entry point and how is this code base really organized. Let's not even get there. Let's just say what would be this entry point, and like let's describe it, right? And then I want to outline and be honest with some of the challenges that people might have with getting started with Substrate and Polkadot SDK. And hopefully, like as I do that, maybe we can have some people in the audience that can also share their experience. So that's kind of my goal. Right in this kind of first half of the stream, I really want to get into that, and then I want to pick things off where we left it, looking at the basic example palette, which, as we learned from actually last stream, what I was doing was kind of going through it and realizing that there's a lot of improvements to be made to kind of make it more basic, to make it more approachable, to make it to sort of highlight the concepts that are there in a more in an easier to understand way. So I hope that's going to be a great episode for all of you guys, and we can take questions as we go. Like that's what we're doing here. So I'm gonna just go ahead and share my screen. We'll do it this way. It's kind of nicer. Yeah, that's just me sharing my Twitter. So oh yeah, so one thing to note, guys. So last episode, I had some music playing in the background. I personally love to have something in the background when I'm going through code, when I'm kind of doing these long form streams. Kind of helps me concentrate. It kind of helps me find a vibe and relax a little bit. But I realized that, well, first of all, because I'm streaming here, I didn't have like I don't have like a bank of like licensed music to be streaming. So I had one choice, and I had this like very boring elevator type music. Well, it was really the best out of the five choices I had that's offered. So until I fix that problem, there won't be any music today. However, I'm still gonna be listening to some jams, and I welcome you guys to do the same. Again, like this format is really to kind of hang out and um, have people ask questions as I go through as I literally go through various aspects of the Polkadot SDK. So I'm gonna go ahead and fire this off. Yeah, highly recommend some lo-fi hip hop beats. That's just kind of my jam. You could be into like heavy metal. You could like, I don't know, not want to listen to any music. At least now you have the choice, and it's not enforced by the recording and you listen and you having this video on. So hopefully it wasn't disturbing, and this episode 0 didn't trouble anyone too much with the background music. But anyways, let's kick things off, guys. So really, like, what I want to get back to is, oh, wait a second, who was at Sub-Zero actually? So that's kind of the first item I wanted to go over, which is so this series will be every week on Wednesdays at 3 p.m. However, we are in an industry of a lot of things happen, right, all the time. So there might be instances where it's just not possible for me to actually make the stream happen, and in those instances, we'll be skipping that week. And why am I mentioning this? Because um, specifically last week, we had a big week. We had Sub-Zero. Sub-Zero is the Polkadot Developer Conference that this year happened in Copenhagen. And we saw so many interesting talks, so many workshops, where a bunch of teams that are building with this SDK that we're talking about today, well, they like literally like an array of talks from very beginner workshops to highly technical workshops. And by that variety really spans more from like the entry level to like people that have been building with the Polkadot SDK for quite some time now. So parachain teams, literal businesses that are using this stack to build their solutions. So I invite you to check it out. I'm going to share the link here in the um, as a banner here. And I mean, let me share that first. Cool. So I wish we had a little. Yeah, that's not gonna work, Sasha. I will share it in the chat. That's easier. Hopefully everyone can see it. So Sub-Zero playlist. Yeah, so hopefully those that are tuning in from YouTube can see that link, and others from Twitch also. I think that the Twitter audience can't see it, unfortunately, but that's okay, because I'm sure that you can easily find it through whatever search engine you use. Sub-Zero, just like to emphasize what I meant, we can really see a whole bunch of content that I really recommend anyone who's either entering the ecosystem, entering this developer world, or even people that are already experienced. I really recommend those people to check out these videos. I myself have a lot of weekend time to kill with watching and catching up on all these. Oh, this is one that I was on too. I did a about like getting started in the Pokemon. So that was cool. Yeah, that was really fun actually. So this panel was basically featuring we were featuring Xylodrone, who's building a grants aggregator, and I mean, like, we're not going to go into like all that stuff, but like, she's an awesome builder in this space who's kind of offering a perspective that's um, pretty unique insofar that really, really more product focused. And then we have Ayushi here, who was, that's awkward, who's a builder in this space, who actually was part of the Polkadot Global Series Hackathon series. Yeah. So, anyways, very, very fun. But I digress. So many valuable talks that have happened last week at Sub-Zero. Let's pick another one really randomly. Oh yeah, so this is pertinent for people that are, already maybe coming from a Inc world, so a smart contract world, and those that that already have a little bit experience with Frame and building blockchain runtimes. Well, this talk talks about the trade-offs and future direction of having smart contracts call into the runtime of your chain, which is kind of cool. Okay, without further ado, let's move on to picking things off where we last left off. Okay, so right. So the Polkadot SDK, I think there's one thing that I missed, or that I didn't go into when we kicked off the series, is that it's really it used to be that the Polkadot repo was its own, this Polkadot folder was its own folder, and that the substrate folder was its own repo. Sorry, I meant the Polkadot folder was its own repo, substrate 2, and Cumulus. And I don't think I really did a good job explaining what those are. And so yeah, we have a question. We have a question from Dexter. Where can I learn the programming language of Polkadot? Dexter, you have come to the right place. Welcome to my Polkadot world. It's not my Polkadot world, but hopefully we can answer that question, and that question will be, the answer to that question will be very obvious. Well, how to say? I hope that this in this session, it'll be very obvious to you what it means to start programming within the Polkadot ecosystem. So at the sort of, just to give you a kind of direct answer, all of the things in this repository is in Rust. So you ought to know Rust. Well, yeah, I mean, Rust, that I would say the Polkadot dev stack is essentially all Rust. It's all Rust until you get to the sort of end user application layer, whereby you would be building user-facing apps with whatever web framework you would of your choice. Typically TypeScript, JavaScript. Rust also has its own frameworks, but hopefully that answers your question, and hopefully you will get more insight as we move along here. So yes. Polkadot SDK had a big merge where all these 3 repos came together. And what are these repositories? Like, okay, let's just ask the question, like, what is this SDK for? Why would I even be in this SDK? Like, what's in it for me as a developer who is really curious in starting to build something in this ecosystem? It's important to realize that as it is now, this entire SDK is really doing 2 things, I would say. It is servicing the development of actual Polkadot as a blockchain, and it is servicing the ability for any team to build an application-specific chain that can be connected to the Polkadot network at a high level. So what you'll notice in this link here, in this repository, yeah, Dexter. Hopefully that hopefully what I just said also like resonates well with you. So we've got the Polkadot SDK made of 3 primary repositories. That is the implementation of the Polkadot node. That is, we're in blockchain world. We're in a world whereby it's a decentralized network of software that is being run that contains the all of the ability for that for the communication between nodes on the network and the execution of the actual underlying logic that the Polkadot blockchain contains. And really that implies a bunch of protocol implementations that make Polkadot really. The other big part of this repository is Substrate. And Substrate is the SDK that is actually being used to develop Polkadot. Makes sense? Like, we need an SDK that can develop blockchains. Why not abstract that as something that could be used to develop the main blockchain that really is what parity technologies set out to build? But also, why not use this SDK for any other team to build their own chain? And now the question becomes, well, okay, so you're saying, Sacha, that I can use Substrate to build my own blockchain? And the answer is yeah. But then the question becomes, well, why? Well, does that mean that it doesn't need to connect to Polkadot, or how can I make this blockchain that I build compatible with Polkadot? So first, to clarify, any blockchain that's built with Substrate can be tailored to its custom needs. It doesn't need to be a blockchain that by definition connects to Polkadot. But in order to make it compatible to be able to connect to Polkadot, we have this third repository called Cumulus. And Cumulus helps developers build their own blockchain that can connect with Polkadot at a very high level. For those that are completely new, you see this term here called Polkadot parachains. I like to just use the word app chain because it resonates with larger audiences. And what it really means is it's an app chain that is able to plug into the security that Polkadot provides as a network. Great dinner conversation, right? You can hopefully what I just said can be distilled in such a way that you can just share with your grandmother or your friends that don't really know anything about blockchains, and you can tell them a little bit about Polkadot. Cool. So what I want to do is also like a little recap of like navigating this repository. So for those that are just for those that are passively listening, that's awesome. Would love to hear your questions, and would also love to see if you guys have any tips, if you have experience using this SDK. But for those that are watching and maybe wanting to follow and kind of follow me along and do like follow my steps and kind of hack away as I hack away, go ahead and clone this repository. Because I actually have it here and we'll be checking it out. after I just continue. I just want to give a little more, high level stuff for navigating this really large code base. I mean, this is a very big code base. Um, so I think it's one of the largest open source Rust code bases outside of the big maintainers of, or sort of the big companies, the large corporations like Google or like the Mozilla Foundation. That's not a corporation, but the large actors in the Rust ecosystem. Um, I think Parity Tech is proudly one of the largest contributors to a Rust code base that is big and mighty. However, we have a question actually from Victor. Hey Victor, cool. So great question. How often are new releases released? So yeah, that's actually a great. Let me take you through the following to answer this question. So in the past, actually, because I can show you actually right now, right? We had Substrate GitHub. It was its own. No, that's not it. Sorry. In the past, we had our own the standalone repository for just Substrate, and it was actually really really hard to release things. Like it was no, sorry, that's not what I meant. It was really really hard to provide stable releases of every of like of a snapshot of Substrate that then can be used and could be like could be reliable for projects building with it. And we had some sort of we had a tagging system. So in the beginning it was a little messy, and then we kind of started just tagging to the we actually started tagging to Polkadot, and you can see here. But my point is, yeah, I mean, there was a monthly cycle, but it was actually really hard because the reason it was difficult to achieve is that Substrate, because Substrate was being used for Polkadot to develop Polkadot, well, but also it was also being stretched out and being developed for other needs. There was so many things that were hard to capture in every single release. It was always it was very difficult to work with in that sense. So having it in the mono repo made it much easier. And now to get back to what you asked, if you go to the releases section on the Polkadot SDK GitHub repo, you'll see that we've had our very first 2 releases. Or is it? Yeah, no, Vue 1.1, and then yeah. So sorry, this is the very first release, and it's Vue 1.1.0 because it was already when this repo was created, the mono repo that we're looking at. Well, Substrate was already at Polkadot 1.0. So this latest release is 1.1.0. And how often are these releases going to be? It's hard to tell right now. But the I don't know about a regular cadence, but what's important for developers and for you, Victor, if you're a builder that really wants to have some stability in your Substrate-based projects, what's great about this new system is that you can be sure that if you're using Polkadot like this, any of the releases that will come up here, that you can reliably use that and you won't have any breaking changes, that this will have long-term support. So to answer the like how much time is elapsed between each releases, I don't actually know, and I don't think we know that for sure yet, but we can at least find comfort in that these releases are a huge improvement really in the developer experience for builders out there. But yeah, great question. Great question. So what we did last time really was I said, okay, I have a few tips. My tips are that, well, first of all, we're not in these first few episodes, we're going to completely ignore everything except this substrate folder. And why is that? Like, let's answer the question, why would I even come to this repository? My answer to you would be, well, there's some, 48 to now, well, actually, there's I think it's 48 parachains. So these are application specific blockchains that use this repository, and each of them are continuing to build. They're continuing to maintain their repositories. So it's just a great skill to have, really. Like, what like if you're a developer that is looking to further your blockchain skill set, learning Substrate is a great place to start to further your skill set. I mean, so what would you be doing specifically? You would be helping develop and maintain the application logic of that app chain, and this is where it would happen. It would happen by using the Substrate library. So that kind of, I mean, maybe someone else in the audience has a better way, or a more concise way of saying, why would you even start like tinkering in this repo? I think that's one that can maybe apply to a larger audience. I have another one, which is just that you might want to start your own blockchain project, and you might be really interested in bringing some idea or some smart contract dApp to a solution that can scale more, that could that a dApp that you could actually improve and tweak such that you actually have your own blockchain for that dApp. And we're not going to go into like smart contracts versus app chains, because that's not really the topic of what I wanted to do today. I actually just wanted to assume that, we all want to learn about Substrate, and we all want to learn about how it works. And it is really tricky. It's a very complex code base. And there's a lot of there's a there's a lot of how to say, like, the challenges kind of present some hurdles for people that are new to this code base. So I want to demystify them. I want to make it easier for you guys to kind of get started. So those are the reasons why I would say, hey, like, why would you even be in this code base in the first place? You could also be just curious and wanting to understand how the Polkadot implementation works. And in that case, you'd be diving into this folder, whereby you can see all of these different primitives and libraries and protocol implementations that make Polkadot. But we're not in that world. Ironically, I've got the Polkadot logo behind me. But what I mean is that we're really in the world of the more generic framework for building Polkadot-like blockchains. Cool. That was a lot of that was a long rant. That was a long rant. What else did I want to mention at this kind of outlining? Okay, the challenges. The runtimes repo, did I? Yeah, so yes. Okay, this is relevant. I'm gonna show you, and I think this is me being like a little critical from my last episode, which is like, what are, like, to answer even further the question of like, what are these libraries helping us achieve? And the answer is that they're actually building these blockchains that are in production, that are being used, that hold multiple billions of dollars in capital, and that secure in a decentralized way applications that are resilient and that are built to onboard the next generation of Web3 applications. So the actual state transition function logic, so the business logic of these blockchains, lives in this runtime repository. And because we live in a decentralized on-chain governance world, this is not actually maintained by parity. This is a repository that only some members of a fellowship. Ethereum has a concept of the fellows, and a lot of communities have this concept of, like, enlightened despots, for lack of a better way to frame it in layman's terms, but really people that are really experienced in the development of the Polkadot protocol, that have a say in changes in protocol, and also that are able to update this repository with the business logic of these chains. Because ultimately, if we look at the Polkadot blockchain and its runtime, the Polkadot network as itself, it is executing some state. Well, the state that it's executing, the logic that it's executing, lives in this repository. And so I thought it was only fair to kind of give you that overview. So if you look at this folder, for example, Relay. So Relay has two folders, one for Kusama and one for Polkadot. Kusama is the canary network for the Polkadot ecosystem, and but it has real value, so it's a live chain, and Polkadot is the actual live network of Polkadot. So this contains the business logic of the Polkadot chain, likewise for the Kusama chain. There's also the system parachains, because Polkadot has these special chains with logic that pertains to specialized blocked app chains for each of these things. And we can imagine in the future there's a lot more of these system parachains. So right now we have asset hubs, so like specialized chains to do asset-like things, and we have bridge hubs. So these are specialized chains to provide bridges to other blockchains into the Polkadot ecosystem, etc. Yeah. If there's any questions on that, feel free to shoot. I can quit this. And dun. Okay, cool. Like, let's just dive right in, friends. So yeah, hopefully you guys have this cloned. We are looking at the substrate folder, and we're going to dive into some examples. We're going to dive back into the examples palette that I looked into it was not last week, it was 2 weeks ago. Yes, remember that SDK Unwinds happens every week, but sometimes we have exceptions because of things like conferences, like Sub-Zero. So, okay. So here we have, I have the SDK cloned, and this is just gonna be a sit back and relax and watch me clarify concepts, run tests, and demonstrate the usefulness of the tips that I gave in the last episode. A quick reminder what those tips were. Oh yes, let's do this. I did this last episode. We're going to. I'm gonna make a scratch pad like I did last time, because the last episode was fun because I was showing some features in the basic example palette, but also while I was doing that, I discovered that some things could be clearer in terms of how things are documented and how certain features are being highlighted. And so the outcome of that was actually me. I can show you guys. I actually just submitted a PR to improve a few things. and currently I'm working on a PR to improve the balances palette. So what's fun for us today is that I have a little bit more insight as to I think where this basic example palette, which so by the way, let me just help you navigate here. So just if you CD into the substrate folder, and we're in frame. What does frame stand for? Can anyone tell me? I'd be interested to hear. You get brownie points, street creds for telling me. CD substrate frame, and then we're into the examples. We're in the examples folder, and within this folder, we have 1, 2, 3, 4, 5. We have 6 different palettes. Historically, I believe that this examples folder was just being used to put in new features that were coming into frame. And so the basic example palette, I think, was really being used to kind of be like, okay, this is one thing we can do here. Let's showcase it. Oh, there's a new API to manipulate some storage items. This is how it works. So actually, if you let's like if you go into that. So we're going to be looking at the basic one. Real quick, then some new ones came up, like how to use some default config. It's I think it's a whole dive in of itself that we're not going to be doing today, but that's just another example of a palette that is really just showing. Yeah, if I show you real quick, we're just really showcasing some features of frame here. And so like, look, this macro, I've I'm not prepared to like dive deep into this, but this palette is showcasing how to use the special attribute or the special with default, and how to, so like no default attribute, for example, is showcased here. And going down the list, kitchen sink. Kitchen sink is one that I know that one of my esteemed colleagues at Parity is working on hard to provide literally a place where like all of the macros you could possibly expect live with examples of them. Off-chain worker. Off-chain worker is a palette that showcases this capability that we can have with a substrate node, whereby you have some off-chain computation that then can write into the chain, to be used with caution. And hopefully, for the curious ones out there, you can dive in, and this palette will kind of teach you why and how to use it. And then we have this split palette. Actually, this split I remember when it was being done from one of the Frame engineers, Nikhil, where there's this idea of like a new feature in Frame where instead of rewriting events, in this case it's events, you can actually just, so if imagine you have a palette that needs to, if you have a palette that has the same events, that shares the same events, then in order to avoid copy pasting them, you can just use this events macro, which I think is like here, imported section. So, and this is, I think this is just showcasing events, but it in theory can do anything. Point being, in this example folder, you have a bunch of really, really great nuggets of gold, right? If you're getting started. And we're gonna take things off from where we were last looking at the basic palette. So yeah, let me get rid of that. And here we are. So yes, I am in the basic example palette. So real quick, we have this lib.rs file is where we're going to be doing things, as well as this tests.rs file. What are the weights? What is benchmarking? We're not going to be talking about that today. We're not going to be diving into these files and doing things there. We might touch on, why do we have weights and things like that. again, like if there's any questions, feel free to shoot. Cool. Is anyone like listening to some tracks? I'm just gonna update my I'm gonna update my tracks. Coffee chill. Music to keep you happy and motivated. Wow. C'est fantastique. I love the videos that go with these long lo-fi beats. Anyways, share your lo-fi beats if you're listening to any of them. That's fun. Okay. Last time I gave a tip, which is to use Rust Analyzer, and I really stand by that because it's a really useful tool that as you're navigating through any palette, any of these Rust modules, like in any Rust project, well, you can actually hover over the different types and different functions, and discover what they do, right? So I really highly I really highly recommend that. Though it comes with a little bit of a trade-off, which is it does take a lot of your CPU. And just to give you an idea, I'm on a M2 Mac, and after having just cloned Polkadot SDK repo and activating Rust Analyzer. So if I go to my extensions here, I got Rust Analyzer going. You can see that it's enabled for this repository. Well, after having just enabled it, it took about 20 minutes for it to run and reach a point where it's settled. In the last episode, I hadn't done that before, so it was a big pain because I was trying to show some tests, but Rust Analyzer uses the cargo lock, so it's doing like a cargo check, and until it's done, it's not able to run any other cargo command until some of the cargo checking is done. To be honest, if anyone knows like how that really works, it's irrelevant really. But the point being is that it's very useful, though you do need to set it up. Like, you do need to like have it run in order to like not get into a bunch of issues. Okay, so let's see from like last time. Actually, so this is what if I connect to GitHub, why isn't that already? Oh, interesting. Oh, okay. So like the last time I actually did some. Yeah, it's not. No, in the last session, I made this PR, and I did this PR based on some of the things that we discovered here. So, we discovered some broken links and basic palette by removing the template. Yeah, kind of cleaning things up. But then that prompted me to continue cleaning things up, which I can show you real quick. And it's still in draft, but like we'll be going over a few things that I'm highlighting in this PR here, whereby the point of this palette is to highlight some key features. Like there's a bunch of things that don't really need to be in there, and as we kind of discover that together, I'm gonna probably make a new palette to demonstrate and isolate some of these features. But back to our code base. So like what do we want to do here? The first thing that I really want to do is to highlight what you would expect just the basic layout of a palette. So I'm gonna be a little daring here, and we're gonna keep this basic palette up, and I'm gonna create a new palette. just to kind of showcase the things that we're going to be picking from this basic palette, but inserting them into like a blank slate. So hopefully that's helpful for everyone. So what I want to do is just to kind of outline the structure of a palette and how you would do that, and then isolate some of these key features in the basics palette. That would just checking some notes that I have. Yeah, very cool. Okay, let's do that. Are we ready? Okay, I've got this split screen. So, you know what? I'm gonna just go ahead and copy, paste. First thing I'm gonna do, just to show you guys, is that if I run cargo test here, I'm gonna run cargo test -p. So on this package. So just a reminder, I said we'd be into these two different files, lib.rs and test.rs. So if you actually run that on any palette, specifying the cargo package, you'll see that the different tests, right? So going a little bit further in this direction, I mean, the unit tests, which I really want to dive into these unit tests today, because I find that it's very, very informative. I think it's a really, really great place to start if you're kind of tinkering with Substrate as a library. And that's because, sure, we could say, hey, why don't we just compile this into and run this chain locally and interact with it? But you won't be really learning Substrate by doing that. And like anyone could just go on, and this is a very typical thing. You go to Polkadot.js apps, and you can literally tinker with all the blockchains that are live there. So this is maybe a link that's worth sharing. But my point is that, so like, for example, this is one of the test networks that we use. We can quit that. And you can get some rocks, which is the testnet token, and then you can be like, okay, so these are all the different modules. So if I go to developer extrinsics, these are the callable functions that I can make to my chain. Then you can see all these pallets, or you can see them here already, and they're there. Like one of like the pseudo palette is a nice and easy one. So the pseudo palette allows you to do very simple things like just specify an account that has super user powers on the chain. It's a palette, right? Like, again, like I'm just showcasing this to contrast what it is we're doing in these episodes from a completely different approach, which is just build your chain and build a chain just really to already be providing a usable runtime, i.e. that you've already decided what your chain is. We're not even talking about that. We're talking about tips and tricks of using Substrate. So real quick, back to where I was saying, the Polkadot.js apps. Well, what we just saw. Okay, so if I scroll down here, there's a pseudo palette that is in this Polkadot SDK, and so the pseudo palette we can see here. By the way, like we could just run the test of the pseudo palette if we wanted to, just like what I did, and let me quit this. It might be just disturbing for now. And everything that is on this live blockchain that you can see running here at this WebSocket, the functionalities of them, we can interact with them. So like I can't actually do any pseudo stuff on this because I don't have the pseudo key, but it's a simple palette that then this app allows you to interact with this user interface. So Polkadot.js apps is just like a developer console. Once you've got a chain running and you've compiled it, it's a great way sort of poke around with it. But it's not really a great way if you want to be learning Substrate. Like, I hopefully that makes sense. I digress. I hope that resonates with some people. Yes. So that's what we're doing. We're going to stay in this code base, and we're going to look at tests primarily as a tool to really understand what it is we're doing. That is, for me, the first of all, the best way to see the relationships between the different types and traits and trait implementations and all the things that make a pallet, this Rust module that contains the business logic or part of the business logic that will be eventually in a blockchain. Well, using tests, by looking at tests, we not only have a really great starting point for exploring Substrate, but we also have an easier way to develop, because with tests, actually, this is, let's say, lesson 1. Let's write that down. Oh yeah, wow, I forgot to do the thing I wanted to do. I'm drifting. Hold back, Sacha. Get back on track here. Yes, because I said I wanted to do a I'm gonna do that. I'm gonna just make my scratch pad. Scratch pad. Yeah, because this last episode, it was a fun little thing we did, which was keep track of the thing of like what we're learning as we go. Hopefully, then that could be used later, or I at least can keep track of things. So Sketchpad it is. Let's say episode 1, SDK Unwind. So let's say like the like takeaways. Some takeaways. I don't know if they are the takeaways. So okay, yeah, like tests allow you to really understand the libraries we use, the libraries used in Substrate. Yeah, it's not okay. Like, I would rephrase that really. So like the tests allow you to really understand like the behavior of the core functionality used, where you'd be building. And obviously, like if you're writing a palette, write your tests. But in our case, we're just also using example tests to discover the behavior, and that also, I think that tests are a great way to easily develop and explore Substrate libraries. What do I mean by that? I mean specifically that if you are constantly compiling down your chain in order to interact with it, it takes a lot of time, right? We're building things to WebAssembly. It's compiling an entire chain is less practical than just running tests and seeing it work in a sort of isolated environment. So that's like a tip. I'm gonna tips tip that we're gonna lean on. We're gonna lean on this tip today, my friends, gals and guys. Tuning in from where? Where are you guys tuning in from? Oh, Justin, good to see you. Cheers. Thanks for the hype. I need this. I'm all alone in the Berlin office. It's like running out of water too. No, that's not true. I'm fully stacked. But it's great to see you, Justin. Cheers. Okay, where were we? Two areas we're going to be focused on. Okay, tests, right? Great way to start. And Rust Analyzer, but we've covered that last time. But let me just show you real quick. For example, like I'm in the test of this basic palette, right? And I am really curious about the blah blah blah. What's a good example? Okay, yeah. I'm in the test, and so this is just kind of showcasing Rust Analyzer. For example, this this whole thing here in this test, not to go too deep in the weeds, it's just setting up the mock environment so that I could run tests whereby we're not, we're not in real compiled to WebAssembly world. We are we have this mock environment where, because a palette has storage, this palette has these different storage items. So you can see dummy is one, bar is another, foo is another. Well, it's specifying the genesis state of that storage. So and then I want to see, okay, then what's this genesis config? Well, with my Rust Analyzer, I can just click to it here. And now I've just kind of hopped into, oh, this is what this struct is. And I get a little more insight and easier way to jump from different types and structs using the Rust Analyzer. So I digress. Okay, yes, what were we going to do? One of the things that was taken away from last episode was that this palette is actually like pretty long. There's a lot going on in it, and we could really thin it down. So my goal right now is to just create a new palette. I'm going to just literally copy this basic palette in the examples. And by the way, you wouldn't be doing this in this SDK if you were really, for your own purposes. Like, this is just to kind of get a sense of how you'd be doing it in your own project. And happy to answer questions about that, to keep things on track. What I'm doing here is I'm just going to create a new basic. I'm going to call it super basic. I'm going to call it super basic. So you'll probably see Rust Analyzer kind of freaking out as I do this, and we'll discover what that is. So super basic. I'm gonna delete this benchmarking folder, this file, sorry. Also, then what we're gonna do is just really thin this down so that it looks pretty, like, really bare bones. Tests are great. Weights.rs, we'll just leave it there. And then, so when you're creating your new palette, what you will always be doing as any Rust project, naming the package, etc. So let's name this as palette example super basic. Whoa. Also, if this was in your own repo, because it's relying on the paths here, this would actually be more like the link to this repository and the branch, which would be Polkadot 1.1 or Polkadot 1, depending on what it is, like Polkadot, depending on what you're, here, for example. We'd go into yeah, it's Polkadot. Yes, this is your tag. But just to give you insight on, like, and then what do we do here? So that's just a side note, but and this would be the Git like Git or whatever. But because we're in the Polkadot SDK, we're actually using the libraries relative to the entire code base, so we're not doing this stuff. I'm gonna not do that, but just in case there's people wondering, like, oh, but that wouldn't look the same in my um at myself. Bum, bum. Super basic. Oh, we don't need the scratchpad here. Okay, so one thing so if I'm gonna try to just run this. Yeah, so you can see that this Rust file does not belong to a loaded cargo project. And that's because it's actually not in the workspace uh, of this repository. So this would also apply to you if you have your own project. Again, because we're in this mega repo. But if I go like example palette, was it palette example basic? This is just a quick trick to search for, where. So it'll be in the cargo. It'll be in the. Oh yeah. So the first thing we want to do here is just this. We're gonna do super basic. And then we're gonna also add this. A tip is just to follow a pattern that other palettes will have. And this is necessary because in this instance, and this won't be applicable to anyone that's kind of just making their own palette in a standalone template, but in this instance, we actually have this examples as a crate, and it has its own cargo.toml. So we have to just do this right now. So example, super basic. Let's see how far we can get. Okay. And you can see Rest Analyzer is it's always that's actually really helpful. Rest Analyzer is kind of always there to. Oh, it's Rest Analyzer stopped. Well, let's fix that later. But we don't need try runtime really. And now I need to go into the manifest. Done. If I go in a new terminal, good. Curious, why did my thing my Rest Analyzer just stop working? I wonder. We'll see. Okay, so clear. Now I'm just gonna do. Yeah, I want to go into super basic. So super basic, yay! So we've got a cargo file, we got our source and a README. We just ignore that. Just copied it, and cool. We're gonna ignore this. I'm not gonna commit these changes, but now if I do cargo test, what's gonna happen? It's gonna freak out, like for sure. Okay, yeah. So this is what I'm saying. Current package believes it's in a workspace when it's not. So it is in a workspace, but it's not in the cargo.toml of this workspace. So let's add that. Let's add it here. So you can see that. So now this is literally at the root of the entire workspace, of the entire code base. And here I'm gonna specify that we have this super basic palette that we just added. Okay. There's no matching package name, palette example, super basic. And it's searched here, but it's required. Oh yeah. Super basic is here. And I guess I just saw that we have a question in the chat. So Diego, you're asking if you want to, like, what if you wanted to test an XEM call? Same concept. So you're it's the same principles as what we're doing here, except that, well, in XEM you could be testing unit tests like what we're doing here, but you could also be trying to test XEM calls in a simulated live setting. So those are just the separations of how it's very different from what we're doing here. However, I can share a link with you with a great resource to get started, to do exactly that. And for XEM, so for context, people that might not know what XEM is, XEM is a cross-chain messaging. Well, for the sake of kind of catering to a wider audience, it's the messaging formats that allows chains to talk to each other. And Diego is asking, how would you test such calls? So I invite you, Diego, but you're maybe a little bit more of an advanced user. I invite you to check out all of these examples where, for example, here there's a testing a transfer, and it's all Rust. We're using the cargo test. They're just unit tests that have some mock environment that's slightly more complex using the simulator, this XEM simulator. Can you see that? Oop, that was way too big. Yeah, so I'll share the link here. This is but yeah, and thanks for asking. This is kind of what I'm hoping that, like, as I'm doing the sort of slow paced showing things as I go, sharing as I go, that there's people that are asking questions and that other people can benefit from too. So hopefully that was helpful to others. The question was, how can I test an XEM call? We have an entire repository dedicated to XEM with its own tests that you can play around with. Oh. Oh, nope. Okay, cool. Oh, question from Kaloyan. Kaloyan, thank you for your question. The question is, it's off topic, yes, but I mentioned this earlier, so it's like relevant because we were talking about Rust Analyzer and like it consumes a lot of CPU. I'm running an M2 Mac, so yeah, hopefully that answers your question. Okay, back to what we were doing. Okay. And one of the things I just want to openly share here is that you're gonna, the Rust compiler is really your best friend. So it's telling me what issues are happening. I want to run cargo test on this super basic palette that in principle I just copy pasted it and it should work, but there's some issues. So what are those issues? Let me get rid of this. It's just distracting me. Well, it's saying that, oh, it just said it again. Ooh. It is telling me that no matching package named, palette example, super basic found. Let's make sure I didn't do a typo. But it's looking at basics. Let's check. Oop. Okay, no typo there. And let's make sure that our cargo file is correct. Still an issue somewhere. Okay. Not belong to a loaded cargo project. Yeah. Look, it's literally helping me. If I say yes, do you want to add it? Yep. Let's do that. What was that change? Yeah, okay, that's what I did before. And I added it there. That's in the, oh, maybe that's what I didn't do. Okay. And then all that, these are the new files. We're going to remove weights too. It's kind of distracting too. Okay. Now let's do test. Oh, it's not happy. Palette example, super basic. Okay. I'll figure it out. Super basic palette. I'm gonna get rid of all of this. It's also distracting me. So all of the stuff that's really not relevant to this palette being super basic. Well, I wonder what's happening here. Look, so it says this Rust file does not belong to a loaded cargo project. It looks like it might belong to a workspace. Okay. I wonder, like, when I say yes, what does it do? Doesn't really do much. Does it do anything? So our workspace members, that's great. Examples. Yeah, always try this workspace. Done that. Okay. I'm gonna just run a cargo check. Palette example. Have it pasted here. Oh no. Palette. It's required by. Yeah, it totally is required by that guy. Oh. Yeah, maybe I just ignore this. I don't want that to add any complication. Okay, that'll keep it. Yeah, I guess just got caught in the weeds of like this entire examples folder is its own crate, but in our case, we're just doing something super like our goal here is to extract these key features in the said to be basic palette, which we'll discover has some really great features, but we want to isolate them in this session right now. We want to just really show some cool features. So let's just get to it, because I think we went a little off track there. Okay, so every palette has like this like top level documentation, which is really useful if you're just moseying around other palettes, because then you can kind of see like what it does, palette overview, and the API for that palette. So I just ran cargo check, and a bunch of things happened. Okay, let's just clean this up. Oh yeah, so we removed weights. We're just keeping it super simple around just the lib.rs file and tests. So all the weight info stuff should be good. I can definitely expect there to be another error. Oh, awesome. Yay. So the question is, what are we hacking on today? So last episode, we went just into like high level like features of this basic palette. The basic example palette in this repository, you can find the Polkadot repo. We're in the Polkadot repo right now. We're in the substrate folder. If I just show you real quick, print working directory. We are in the Polkadot repo, substrate folder, frame folder of that folder. And you'll find this examples folder with their palettes, their Rust modules to showcase some key features of the frame library. Frame is the way to build custom palettes, i.e., the building blocks of your substrate business logic, your substrate chains business logic. So what we're doing today is that we're going to thin down all of the stuff that's in this basic example palette, and then interact with some features by using the tests. So just unit tests, simple mock environment that just provides us a way to hack around with some of these features. And what are those features? Let's just dive right in. But thanks for your question. I hope hopefully that also sums things up for other people that just tuned in. So what are those features that we're going to look at? Well, the first thing I want to do is kind of like strip it down so that we really just have a basic like a palette that compiles, but I'm going to write this in the scratchpad too, so it might be useful for others. So scratchpad. So what we're doing, show super stripped down version of a palette that can compile. Thanks for your question, actually, Kaloyan. You're forcing me to put a little structure here, and hopefully that will be really helpful for other people tuning in too, right? So what we're doing is we're gonna show a really stripped down version of the palette. We're gonna have the basic palette as it is, which is available in this repo, next to it, and sort of highlight some of the features that it showcases inside our bare bones palette, and we're gonna iterate as we go. So show super stripped down version of a palette that can compile, and then add some of the features from palette example basic to show. Cool. Engaging topic. I hope so. I will say that, like, if you're just starting with Frame, this is maybe really great way to dip your toes. If you're like super advanced, this is probably not, well, I was gonna say, like, if you're already like, a Frame developer and you're building your own parachain already, like this is the equivalent of like a 5th grade math class to a senior high school, math class, or even some calculus class. The analogy really to depict that, we're really going through basics here, and I think that even those that are experienced, those people could also learn from the tips that I'm sharing, and maybe people like you, Colleen, can also share your tips. Okay. Okay. So add some features to the basic palette, and then show some basic tests. Because one of the and show functionality in tests. So one of the things that this is my key tip of the day is tests. Tests really allow you to discover the different parts of substrate. Back to it. Okay. So right now I'm really stripping this down, and let's get rid of everything so that we don't need to. I'm just gonna say like this is a super basic palette. Okay, so super basic palette, great. So every palette essentially needs a bunch of imports. We're not going to touch these for now because I'm not sure what, like as I remove things, we'll see what is not being used. My ID is going to tell me basically, so that's kind of useful. But so we got imports here, going through the sections. I'm going to make my terminal a little smaller. And we've got re-export the palette items so that they could be accessed from the create namespace. And then we like our module test, our testing model, because that's the only other module we're using. I'm going to ignore this for now and continue stripping this down. So every palette has a configuration trait. That's great. We're going to keep that. Remember, every palette must have a configuration trait, and that's very key to any palette. This is the struct. Maybe I'll get back onto this, but essentially, like everything that all these macros that we can see here do, like decorate this struct with different methods and types and stuff. So that's what we mean by it's a placeholder we use to implement traits and methods. Typo there, but let's do that. Okay, hooks. We're not going to look at hooks. This was something that we looked at briefly on the last episode, and it's something I want to actually I want to highlight as a standalone topic. So we're not going to look at hooks, but if there's any questions about hooks, I'm happy to try it out. Take them. This is the call declaration. We're just going to leave these comments here because it'll just help us navigate, but I'm going to delete the rest. But there's a lot of material we're just deleting to strip this down and continue stripping this down. I think this is very like legacy or back in the day, because I remember what in case people are tuning in, what I had mentioned before is that this examples folder in the frame folder, well, it contains palettes that were being used like as new features in frame were being developed. So like we'll see, it highlights certain features in frame, and this examples folder contains other palettes that highlight other features in frame. Right now we're just looking at this basic one. So so we're gonna the call declaration. So every palette has a config trait. Have to keep that. I just collapsed it for now, and it has a call block. Not every palette needs a call block, by the way. Question. This might be a good question to ask after this stream, and I'm gonna jot it down. So the question is, what are the mandatory palette parts? Question. Kaloyan, your comment I think is funny to share. It says, no matter how advanced I feel, I am in a field. Going back to basics always improves my knowledge. The more iterations, the better. This is a joy to watch given my experience with Substrate. Thanks so much. Yeah, hopefully it's a joy for you too. Okay, so this is going to be a question that, I mean, feel free to, if anyone wants to answer it, it'll maybe be a fun little like follow-up from this stream. What are the mandatory parts of a palette? Back to my super basic. This is something I created in this repo to showcase it. Boom. Let's keep going. Because yeah, I slightly digressed there because I said that this is a must-have, but the call part is not a must-have. And I'm going to show you by compiling it, but I'm going to continue deleting all the stuff that's like going to distract us. Keep it super simple. Okay, cool. So now we've arrived at the part of our palette that, okay, these comments are good, but you have me talking, so I can kind of just do the talking for you. Yeah, reporting. Let's just simplify it. Okay, boom, boom, boom. So events, I'm gonna collapse that too. Storage. Back in the day when this basic palette was made, we weren't really sure how to use proper commenting. But okay, that's just like a doc thing. Great. So we're just gonna put like storage items. Storage. And we're not going to do this the whole thing. So there's a map. Okay, so we've arrived at the part of the palette where it's just all the storage items. I'm not going to remove any of them because my goal right now is just to like thin it down so we can just get this to compile and then we'll slowly iterate. Main implementation block of the palette. Oh yeah, so this is the main implementation block of the palette. Great. So we'll keep that. We'll keep that for now. I'm going to collapse that too. Okay, this is okay. So right now we're looking at a huge block of comment, and it's essentially explaining one of the features that the actual basic palette. Remember, we're in super basic right now. We're trying to thin it down, and well, the actual basic palette is showcasing some really neat feature that, for the purposes of like right now, we're gonna ignore that. What is that feature, you might be wondering? Well, it's this feature called a signed extension. It's a signed extension. Anyone knows what a signed extension, feel free to share in the chat. But again, for the purpose of keeping things a little focused today, we are not going to indulge. We will not indulge in signed extensions today. Okay, we've kind of thinned it down. Let's see how it looks. Okay, so look, we can already see a lot of imports that won't be used. As my Rust analyzer, you can see cargo check is chugging away. Okay, so let's get rid of this. Let's get rid of everything we won't be using, just for the sake of keeping it. Like all of this transaction validity, sign extension, we're not using that. Boom, we're not using that. We're not using that. SP runtime. Oh, see, like magic of Rust Analyzer. Highly recommend it, right? You can just go directly into the docs within your IDE. Okay. Ooh, we've got a contender. We have someone whose name is Justin, who's taken me up on what a sign extension is. Again, we're not going to go deep into this, but this is a fun thing that this palette does showcase, the actual basic palette. So a sign extension is custom behavior that acts on all incoming transactions. Yeah. Yeah. We won't. Yeah. Like we won't go into it. Like it's like essentially, signed extension is one of these really cool features in Frame that can that acts on incoming transactions. And that to piggyback on what Justin is saying, well, um, I with Frame, with palette development. In fact, I'm glad that we're just kind of slightly taking a detour, because the question always becomes like, why would I even build a palette? Why would I even write a palette? Why can't I just do things with smart contracts? And um, well, with smart contracts, you can't do things like signed extensions, and hmm, but what is a signed extension, Sasha? Well, we're able to actually specify some logic that when a transaction is in the transaction pool, that is checked, and a certain transaction can have different behavior as it is imported into the block than others. So we can really program. We really have more programmability on the types of transactions, the types of uh, extrinsics or calls, or yeah, the types of data and how they behave as they are put into a block. And a signed extension allows us to do that. But I think maybe this is something that we can check out on one of the next episodes. I'll write that down on the scratch pad. Thanks, Justin, though, for that. It was like spot on. Also shows that you've probably dabbled with Substrate a little more than someone that might be completely new to that. I'm gonna add to my scratch pad follow up. Yeah, so like signed extensions are interesting. Why? Cool. Okay, so a bunch more. Yeah, we don't use this. We don't use that. Dispatch class. So yeah, we we don't have any of this stuff. We don't use any of this stuff either now, and it kind of keeps things pretty simple, more simple. I think all this frame system, all of this is not needed. In fact, this was like some legacy stuff. All this stuff is just really not needed. Okay. Okay, let's continue and just keep the focus on stripping this down and then making it compile. So what we have is like every palette has the following sections. It's got a mandatory field for like the palette configuration. So this is really just a trait that allows you to specify the type, the like types that this palette depends on. And why is it mandatory? Because I've already told you that. Wait, no, sorry, that's I put it on the wrong. That's not what I meant to put. It's here. I wanted to put that here. So the palette configuration trait, and why is it mandatory? Okay, we don't need this magic set number. Is because every palette will need some like every palette depends on a let me go to the docs here for you guys. Actually, this is maybe we go like this, loading. If I go like this, okay, yes, right. So the purpose of this trait is to act as an interface between the palette and the runtime. A type, function, or constant in this trait is essentially left to be configured by the runtime of this palette. And I'll just give you guys a sneak peek of where you'll be able to see for yourselves what palettes are mandatory, what parts of the palette are mandatory, what parts are like optional. And I hope I'm correct in saying that. I mean, yeah, I've never. Let me just show you guys. Yes, it is mandatory. You can see that this is a mandatory attribute of all pallets. And this is, my friends, actually a super, super useful resource as we're going through. So I will share it here in the chat. Super useful resource showing all macros, all palette attribute macros. And there's a lot of macros, right? We certainly won't be going through all of them in this example palette, but my point is that this is a mandatory component of this palette. So just continuing on the structure. Wow. Okay, boom. Okay. And, oh, that's not what I wanted to do. And, okay, palette call. Palette call block. Every palette has a call block. I'm going to collapse that. An event. Yes. Okay, let's see if this compiles. I just took out some comments. I just want to prove it to myself, though. I do cargo. Oh, let me go into the. Oh no, yeah, I have my other terminal I'll use here. Second. One second. Yeah. Okay. Cargo check. Let's just do a cargo check again. Wait, because it wasn't compiling before. Okay, wait info. It's still complaining about wait info. Oh, because well, let's get rid of this. Let's completely get rid of this and just roll with it. How about it? Because wait info ultimately in the super basic palette, we're not using wait info. Wait info is really just a way to configure the wait for a public call, like a callable function. And the reason why it was here in the config is that everything in Substrate is made to be super generic, right? So everything in this palette actually is generic until it gets implemented inside of the runtime. So that means that when this palette, like all of a sudden, we want to actually use this and compile it to make the runtime of our Substrate chain, that's where we'll specify what the event type is. That's where we specify what the wait info is. Like if we had another, if you look, let's just quickly look at this at another example. Well, actually, in the basic example, we had this constant value called magic number, and magic number right now it's just a type that we know must satisfy this trait bound, this implementation, so of get and it's some balance. So we know that however it's configured, it needs to be of this type. Likewise for wait info, there's a special type wait info that a runtime will have to configure this. So, but we've deleted that because it's not as part of what I at least call super basic. That is gonna create a bunch of errors, but we'll roll with it. Okay. Yes. Okay. Always look at your errors. Boom. So this pallet call, to make it super, super basic, we're actually just going to put 0 here. Right? Will that work? Should work. So the first error that we got is like, okay, there's no weight info. Well, yeah, we just deleted it. That was in the config. What else? Yeah. Okay, yes. Method not found in. Oh, did we have this here before? Maybe we still needed that. Oh, yeah, we did. SP runtime. I'll just put that back in. Oh, damn. In our annoying thing is with the REST analyzer is it's sometimes your code editor just freaks out. And it's just a little distracting. That's fine. Okay, we're getting there. Wow, weird. Okay, so the call. You know what will be really easier here is that I'm gonna just get onto a branch where I'm gonna to stick to our goal here, because I think that I don't want to spend time necessarily like stripping it out, testing that it all is compiling, and then inserting things back in. I kind of just want to start fresh, and for that I actually have a little branch where I have a shell palette. I have a palette that I've been working on to. I'm gonna just do a little thing here with my Git. 1 second. This hopefully will be useful for people where literally boom. Should have done this before. Okay, we're back. So I'm literally I've fast forwarded in time here, friends. What did I do? I took a like a template that I had for making it easier to start with all of the necessary components of a palette, which ta-da-da-da, what do we see? Like literally, it's sorry, I'm scrolling too fast. It's the config trait. So I'm gonna go back to what I had here. Palette. And I wonder, is this, I'm gonna cheat here, but all is not mandatory. But we're gonna keep it in there. I'm pretty sure call is not mandatory. Like, yeah, it's optional. What are the ones that? No, I'm not gonna check that now, because then you guys will. Well, you know what? People that are watching now, kudos to you, or lucky you guys, because if we do a palette is mandatory. That's it. Interesting. Great. I'm gonna win this quiz if we do one. Back to it. Yes. Whew. So now this should compile as is. Let's just do that quick. Cargo check. What is he doing? It's too fair. Cargo check. Pallet. Super. Cannot. I'm gonna remove this too. No, we're okay. Working there. I feel like it's just a little bit. We need to let Rust Analyzer chug along here. Let's let Rust Analyzer chug along. Ooh, I wish I had a better chair in this office. I really need to keep a good posture here. Sorry, I missed one comment. Yeah, man. Exactly what's happening right now. Yeah, and any idea how to make it faster? What I would suggest is like use the Polkadot SDK repo to reference things. You know, for example, if I want to see what other I don't know, like we're looking at this basic palette. I'm curious to see other implementations of, or I'm just want to show you an example of like, I don't know, I want to see another storage map. So like different storage maps out there. This is one storage map. And then, you know, I'm using this code base to like reference some examples. That's a really like one-on-one tip. So, you know, using it for that. For anything where you're actually doing your own development, I recommend that you isolate it into either your own node template or your own palette crate so that Rust Analyzer isn't doing so much chugging. This is something that I'm learning the hard way right now, live streaming. But totally, you're not alone there. Yeah. Okay, so I'm gonna just continue with this whole thing. Start a little fresh here. Split screen. Wow, it feels like hours ago. This is where I want it to be. Okay. Let's double check that. So I've got my terminal here. Basic. That cargo check. Palette. Example. Basic. Which is the one that we actually have. Okay. Oh. Rust Analyzer. Well, how's everyone's week going so far? What else can we talk about while Rust Analyzer analyzes? Yeah, as you can see, this is something I mentioned in the very beginning. It's waiting for the log file on build directory in order to. Yeah, maybe this is probably not. This is something that I'm going to do for the next stream, which is when we're hacking around at something, like go outside of the Polkadot SDK repo, because it's really hard to quickly iterate and stuff. Okay, so we don't have mod. Yes, yes, yes. We remove that. Now, what we want to do is add some of these basic features. I'm gonna a little bit pivot instead of trying to show every step. We're just gonna go right into it with the features that I want to highlight. The very first feature that any frame palette will have is the ability to store something. So the in this example palette, we have storage value. It's a loading. Yeah. So if Rust Analyzer was actually working right now, it would come up as the documentation for what the storage value does. And essentially, a storage value just stores one value in storage that this palette will probably implement some logic to manipulate. So in this case, just to give the example, we're storing some balance. I'm going to go ahead and copy this over because this is going to be one of these features that I want to highlight. We're going to need to update this config trait, but I personally like to always include my storage items right after the configuration trait, or at least in that order, whereby it's never like too far down the palette. This example palette actually has the storage items after events, and I personally don't think that it's very intuitive, because I'd like to see sort of as a starting point, if I'm reading a new palette, what this palette stores, because storage is like everything, right? Like this palette's logic um, um, really like depends on it's like manipulating some data. If it's this what this palette does, and in this case we're talking about storage. Of course, storage is not actually mandatory, but in our case, it will be. Let's see. So what's cool is that this is a macro that will do all the sort of storage layout for us. Frame is really powerful because it has these macros that do a lot of the work for us. And one of the macros, or this attribute procedural macro getter, allows us to specify a function that allows us to retrieve whatever that value is in storage. So this is the syntax that you should expect, where we have a storage item called dummy. It stores some balance, and that's that. So let's try to compile that. Oh, did it do that thing again? Let's see. Oh, because I switched it. Here we have a switcher. Bear with me. Oh, we have a comment about Rust Analyzer stuff. Yeah. Yeah, I don't know, NeoVim. So Kaloyan says he's noticed that Rust Analyzer behaves slightly better than NeoVim, but then the delay comes from me not being as fast as an irregular IDE. Right. Yeah, I'm not sure. I mean, I've only ever used Rust Analyzer, so I don't have anything to compare against. Okay, let's get this done. Could not locate working directory. Oh, it's confused. It's so confused. You know why it's confused? It's because I did a quick git switch punching stuff. So just give me a second. Get back into our basic. Oh no, frame examples. Super basic. What? Oh. Okay. Now let's try to compile that cargo, or let's just check it. Cargo check, super basic. Oh. Now for our purposes, I might just switch it off right now. This REST analyzer. Like I hope I've emphasized enough that really it's just a nice tool to discover documentation. Actually, this is also what I did last time. We had the same issue. Sacha. I'm going to disable it for this workspace because it'll allow us to iterate faster. So it's just going to reload. But while it reloads, I mean, it'll take a second. I'll like, for those that have this issue, which is very common, and also you can't expect that everyone has like, a very, very powerful computer. I've disabled it, but for those that have this issue, we're going to be using this for anything that comes up, like what we did, like, a signed extension, and this is a great alternative to actually go and check the docs as you're working. Of course, REST Analyzer is useful because it's right in your IDE, but this is a very equally valuable alternative where we're just using the actual rendered documentation itself that's at this URL. Okay, yes. And that'll make things easier for us, hopefully. Yes, so look, it actually compiled and things are happy. Yeah, if there's any tips on REST Analyzer, I think I remember when I was at the I was with a bunch of students learning Substrate, and one of them actually had some remote setup for running REST Analyzer and configuring configuring some way to like toggle it on and off. And I don't know, I'd love to learn more if anyone has like some tips. Some tips there. Okay. What are we doing now? Oh yeah. We're back. Yeah, so this is going to be much faster now that we have this set up like this. So let's put in our config trait. Oh, this is also super basic. I want to have this one up, so we can do both like this. And just to kind of give the high level here, we're going to show how to make a callable function in this palette that mutates this value. And two ways, like either just completely setting it, like resetting it, or being able to change it by accumulating it. And this is all in the examples in the basic palette, but I'm isolating it for the sake of us learning together. Okay, config trait. I'm gonna copy this. One trick is like just easily find where you need to go. Trait config. Every palette will have every palette with events will have this event type, and well, I'll save it for now. But in the config trait, let's follow what the compiler is telling us. So scroll up here. Unused associated type balance not found. I'm going to check where that is. Okay. Because in our storage value, we have this balance type. Where can we have this? How can we configure our palette to have a concept of balance? Well, in the basic example, you'll notice that we actually import the balances palette. And here, if I go palette balances and I check, we have it in our cargo palette balances. So let's go ahead and add that. The reason why we actually have this balances palette added to the palette we're working on is because in order to derive this balance type, we want our configuration trait to include it. So we want to be able to add all of the types of the balances palette from which there is this balance type in our code, right? So that's what we're doing right now. Go ahead and add, oh yeah, and the cargo of our super basic. Great. Dependencies. Oh yeah, sorry. No, we're doing that. Up. And then we're gonna do this thing called tightly coupling. We're gonna say that this palette really has a intimate dependence on the types of the balances palette. And you can see we're just copying it from our example. By the way, this is an entire like deep dive of we can do like examples of balances. And now when we call T, so this generic T balance, this should compile because we have this associated type now on our generic T. Because T, as you can see, is bound by the configuration trait of this palette. Oh, there's something wrong in my cargo file. What is wrong? Oh, is it already there? It's already there. Oh, I just call, I think yeah, Sacha. There was two of them. Great. So that actually compiles. Let's keep going. Okay. Kind of weird to see this config trait MCs. I'm like personally not used to it. So now what we're gonna do is we're gonna write a call. So this call is gonna allow anyone from the outside world to make a change to the storage item. So if I'm like on the left, I have the actual our reference example. We'll just copy it over. And notice that we like every call has this like wait annotation, and what we want to do is we're not going to go into like what weights are, so we're just going to set it to 0. What I could do, and I know I could do this, is I could actually do something super simple. Actually, this is a tip that I will share and put it in my Scratchpad. What I can do is use this feature in Frame called dev mode. Funnily enough, in our examples folder, there's an entire palette dedicated to showing how to use this feature. But we're just going to do it, and maybe some questions can come. I don't know. So use dev mode. Okay, what have we here? Use dev mode. I'm gonna wait for the compiler to complain and then use dev mode. But dev mode is gonna allow us to completely ignore anything that has to do with specifying some weight for this call, because we're gonna try to keep things focused on actually making some like creating a publicly callable function. So what you can see here is this accumulate dummy. This function is super simple. It allows any public or it allows any external actor to call into your blockchain ultimately. So Frame has this really neat feature. Hey, Rust Ninja. Cheers. Nice to see you. Yeah. Oh, I really like your content, and I hope that you put out some more stuff. It was great, great. Great speaking to you at Sub-Zero too. Cheers. Really nice to have you around. So, what I was saying is now we're gonna dive into this like core feature in Frame. Really pillar feature, and it's really a pillar feature of this Polkadot SDK. There's a concept of the types of entities that are allowed to make special calls. So in this case, we're gonna make this call, and I'm gonna just copy from here. So let's just go ahead and do it ourselves. So there's a call. I don't think we need call index. We're gonna ignore call index. And we're gonna say pub function accumulate dummy. And every public call needs to specify the origin. This is a key concept in Frame. It's the concept of an origin, which is the type, the entity that can actually execute this function. Call this call. Make this call. Origin for t, and that really, this is this powerful way of thinking about composing any logic in Frame, which is that these entities can really be of 3 types. It could either be signed, like your traditional end user needs to sign this transaction and pay fees to interact with the chain. It can either be unsigned. That's more of the type of information that or type of transactions from like off-chain consensus world. And then we have this other origin called none. And none is an origin where that entity could be maybe another pallet. It could be maybe some it could maybe only be executed by some on-chain governance motion. But right now we're focusing on just this. It's a signed origin, right? Because we're going to allow anyone to change the storage value by calling this function. So oh yeah, when we have increase by, I'm just going to copy the rest of this here. Dispatch result. And up. So the first, so what we're checking is whether the entity calling this function is actually a signed entity, is actually an entity that is signing this transaction. So we say let sender, just literally copying from there, ensure signed origin. And it'll throw an error if this origin is not signed. Great. And here, this is something that is in the examples that I really wanted to just highlight, which is this mutate, right? Where it's kind of a really elegant way. This is my nitpicking Rust syntax, and it's an elegant way to actually change the value in storage. Okay, so what are we looking at here? Well, there are 3 lines of code is using this mutate API to take what value is in storage, dummy. So reminder, we have one single storage value, and it's storing some balance. So this publicly callable function, so here I'm going to just say like check that the caller is signed. This publicly callable function is just takes in a balance because the user is going to just increase that balance. And type balance, so it takes that. It says, okay, let new dummy. So what is the new value going to be? And then we're going to put that. So it's a closure that's calculating that new value and then updating it in storage. And it's a really neat way. I mean, it's a much neater way than doing something like I'm going to just check if this compiles. Oh, we've got some basic issues here. Oh yeah, so call, maybe we need another curly bracket. Do-do-dun. Do-do-dun. Oh yeah, I did something silly here. That's what I did. I meant to put a bracket instead of a comma. Let's try again. Okay. Palette call requires either a concrete wait. Okay, here we are. This is actually a really nice error to see. Substrate's come a long way. Before, it would kind of just give a bunch of random errors. Now it's telling me what I expected. I expected that there would be some issue with not specifying a wait. Notice that, like, in this basic example, like, there is wait. Wait is a really, really important concept. But if we're doing like what we're doing right now, we're just kind of demonstrating some features and we're maybe hacking away at a palette. Well, we don't want to worry about something like wait, which is really more for production chains. And so like it's really more for a palette that is going to production, where you need to care about things that might affect that might lead to your blockchain being attacked by not having enough resources to do computation. That's what wait is in a nutshell. It's to specify the amount of resources that will be needed to do this call. But because we don't care about it, we're going to use dev mode. here we are. Dev mode, enter dev mode. And dev mode. Yeah, so like I said, dev mode actually has its own palette, and its own example palette. So, but I'm gonna not do that. I'm going to show you how to use our Rust. Like, I mean, this is a good. It's a good segue into just showing how we can use our Rust docs. So, dev mode. Oh yeah, no, but this will be more in the. Okay, so this is like a holy grail. Like I will re-emphasize that this is the holy grail of what all these little attribute macros and frame do. And here I should be able to find something about dev mode. There you go. So dev mode, specifying the argument dev mode on the palette attribute will allow to enable dev mode for palette. The aim of this dev mode is to loosen some of the restrictions and requirements placed on production palettes for easy tinkering and development. Dev mode palettes should not be used in production. Enabling dev mode has the following effects. It's literally saying like all the things you need to know about dev mode. And what is awesome is that we don't need to specify weights. So that's going to help us in our case. Right? So let's just to double check how this syntax works. I'm pretty sure I know it, but this will explain it here. Hopefully this is not too messy with the split screen. I can totally understand if it is. If it is, please someone say it, because then I can just figure it out differently. But here, dev mode. Yes. So all you need to do to enable dev mode for a palette is to just pass it in to the this palette macro. So let's do that in our own palette. So if I pass it into this here, it should work. We should be in dev mode. Let's see. So what we expect is it's at least right now the compiler is not complaining about not that, like there being no weights. Okay, so let's see. Saturating add. Okay, cool. So that worked. So now we're on to the next issue. From the compiler is complaining about something about this saturating add, and I think that let's see. Maybe we just need to import something we don't have here. Yeah, it's SP arithmetic. Let's just import this. I don't know, just to be super sure. SP arithmetic. I'm pretty sure well, let's just roll with it and aim to make it compile. Use cargo add work. Let's see. Back. No work? Hey, it's compiling. So by little trick, I just went straight to the rest docs, saw that it that SP, so the thing that it was complaining about, which was the saturating add not being there, I just added it to our scope, to our Rust folder. Okay. Oh, I wonder where this got it from. If we had the Rust analyzer, we would. Okay, I really want to get to tests before we wrap up today, so hopefully we can do that. Hopefully we can do that. I really, really want to. Oh, sweet. We're good with this split screen. I'm just catching up on some comments. Oh yeah, Rust Ninja, you're asking if I can point to some source code related to proof of work substrate example. Let me think. I'm thinking off the top of my head. Wow, it's been a while, honestly, man. It's been a while that I'm. It's been a while. I feel like years ago there was some repo somewhere. I'm not sure. I'm really not sure at this given moment to answer that question. So proof of work substrate example. If anyone that's watching can share in the chat, if they know of a place, then please do. But I'm not too sure about that. Sorry. Righty, right. Okay, let's get this done. We're gonna do tests for this. I promise you guys. We're doing something super basic. It's so basic. It is so basic. Right, yeah, something that's up to date too is also a different story, because if it's years ago, it wouldn't even be this type of substrate syntax. And it's come a long way. Substrate has really, really come a long way, I'd say. So, okay, we're in dev mode. Amazing. Dev mode is there. We don't need to care about weights. We have some simple dummy storage, tracking balance, and this call. This is not the pallet configuration trait, Sacha. This is the pallet call block. Let's call it. Okay, pallet call block. This first call that we're creating is called accumulate dummy, and we are literally just doing one thing. We're using this mutate API, which is, I mean, I invite you to just go and check the Rust docs too here. So mutate, and it's on storage value. This is an API. This is an API. The storage value API has a bunch of functions that we can use on it, and right now we're using this mutate API, which, by the way, we can improve the docs there. I think I'm going to just note that. That's a note to myself. And then we're actually, oh yeah, saturating add. Okay, why do we use saturating add? I'm gonna put that in the scratchpad as a like follow-up question. Why are we using saturating add? Why? And please, if someone watching right now can answer that, that'll be like a little fun experience for me to hear your response. Why is it that we're using saturating add? We're using this function that we've imported from where did we put it? Here, the SP arithmetic, to actually add our value. Because look, I'm gonna just highlight this. All right, finish now. Why are we using saturating add? And this comment, it's already, it's like spoiler alert, because we could just do a simple, we could just do this, right? Why don't we do this? And hopefully someone can answer in the chat. But it's an important piece as you're building your pallets to consider, and to avoid using your traditional arithmetic operations. So we're using saturating add. Okay, let's try to compile it now. Okay, there's some issues. We like issues. There's no result. Really good. Okay, let's keep going. So this function accumulate dummy returns dispatch result. Dispatch result, again, check the Rust docs. Let's do that real quick. What does dispatch result do? This could also be a little bit improved, but basically what is an automatically converted augmented type should be used whenever post dispatch info does not need to be overridden. This should be a common case as implicit return type. It returns a either an error, right? Or it will return this unit type. And what is missing in our function right now, sorry, multitasking, putting it as a follow-up, for me, notes, improve. The one, oh yeah, also on mutate. We'll do that. Do that to make it clear what these things do. Back to my actual palette, what we're looking at. So if we return, oh, this function needs to return something. It doesn't do anything right now, right? Let's return something. What are we doing? And we'll just return OK. Return OK with a unit. That should work. Yes, that compiled. Amazing. Oh. Emphasizing the docs was a good thing. Saturating as the numeric bounds instead of overflowing. Yeah, thanks. Like literally, that's what it says in the docs, right? I'm I'm not sure. I didn't check, but we looked at that. So totally, we want to be careful when we're doing arithmetic, and we don't want it to overflow. So saturating add gives us that functionality to create some bounds so that it avoids overflow and throws an error if it does. Cool. Let's write a test for this now. Yeah? Let's write one test for this. And that'll be, I think, a nice little. So notice, like, literally, this doesn't even have a. This config trait is mandatory, remember? But we don't have like in the other, sorry, in the basic example, we have a bunch of things in our config trait. In fact, no, we really just have this runtime event, but we're not doing events in this super basic palette. We're just doing this one storage item and this one accumulate dummy. Cool. So back to this. I'm gonna wait. Should we do anything else interesting? I don't know. What do you guys think? Should we could totally, add more from this palette, but the main thing is, oh, storage item, it's a storage value, and then we have one callable function. And we also looked at dev mode. If people watching right now are curious to include anything else from this example palette, feel free to just be like, hey, Sacha, actually, it would be really cool to do this other thing. But let's try to keep focused. It's kind of my goal. Yeah, you can see here, we didn't actually do this in our super basic palette, which is deposit an event. But it would be cool to do deposit event. Should we do? Okay, let's add a test for it, and then we can extend later. Yeah, let's do that. Okay, cool. Thanks. Sweet. So I'm going to. We need a mod for it. We need to create a testing module. And for this, I'm actually really gonna copy from our. So we're gonna do like this. So this is our testing module. And we are gonna go and add the config. I don't know what the CFG stands for. I'm not sure right now at this point. Some REST feature thing. I'm not entirely sure. Okay, boom, and then add this module. We're gonna copy paste it, delete most of it, and write a test just for this dispatchable that we wrote. I'm going to copy this test, super basic tests, boom. Okay. Cool. So I've just stretched my screen so that we're just looking at the tests of this super basic palette that we are working on. Right, the crate. We'll go through what this file, like the lines of code in this file, but at a high level, we have the mock testing environment, and then at the bottom we have the tests. It's common within Substrate and frame and this frame repo to see that the mock is its own module and the tests are in its own module. But for now, by the way, I'm still listening to tunes. It's keeping me going. I still got a little bit in me here, but probably keen to wrap up in not too long, given that we've been streaming for like about 2 hours and a half. Okay, are you guys listening to tunes? I'm listening to some lo-fi beats. Okay, boom. Example super basic. This is great. Okay. This is part of our mock testing environment, and oh no, example super basic. And we have the balances palette. Why do we have the balances palette? Well, simply because that's a part of of how we've constructed this palette. It's complete choice that we've decided that we're taking the type that the balances palette provides. And that's what, when we did this here in the configuration, we literally said, okay, we're gonna bound our config to balances config as well as frame system config, which is mandatory. You always will have frame system config. And why did we do this? Because we want to simply be able to refer to a balances type by saying, T balance. Pretty straightforward. Hopefully that's like that's so now why in our test environment do we have so let me quit that. Do we have the balances palette? Well, exactly for that reason. And we have super basic. Well, I won't. This entire code block that we're looking at is mimicking how the different palettes of this mock runtime environment would be created. So you'll find that this macro exists in like real runtimes in production, and a neat little way to just verify for yourself. It's kind of fun. It's like, ooh, what other chains are out there, and in this mono repo. Let's go out of, if you do construct runtime. I'm gonna keep focused, but I invite you guys to check, like do a little scavenger hunt on where construct runtime is in the lib.rs folder file of the runtime folders of different chains. Cool. So we have implementation for test. Test is just a struct, right? It's an enum, which is a structor, arguably, and we're implementing the traits that we're using for test. This is where we're at, where I've really started by saying that learning, like starting with just like test is actually very valuable, because instead of getting into the weeds, like a lot of material is taught out there about, okay, just start with a node template, put your palette in there and just run it. Well, taking the time to appreciate a test mock environment is very valuable. So we're implementing then balances also for tests, but that's all we need for this palette to actually run our tests. And then this is our actual config trait. So I copied this over from the other one. We don't have anything here, remember? we don't even have an event, so we should be able to just write a test empty. But we still need to implement our configuration trait because it is bound by the frame system and palette balances. So now testing environment means we need some mock database, right, where we're going to be writing these things to storage and just testing them. And we're also going to have an ability to use frame system, which has so much great stuff that I'm completely skipping over for the sake of moving forward with our feature here, which is this palette has a storage item and some API to mutate it. Well, we this frame system, guys, maybe let's just do a whole deep dive on frame system and like mess around with it. But this is what I'm most excited to show you guys is that we're going to be using the system palette as we do tests because we might want to move to the next block. Like that is something that the system palette does. And okay, I'm gonna leave that thought there. So we need to produce this environment, and right now, I think that I wonder what's going to happen here. But from our basic example palette, which I'm really basically saying like we can be so much more basic. So this is a super basic palette. Well, here, so I'm going to go to the left. You'll notice that we have this weird macro called Genesis config. And in this, we actually we specify some value in storage. Thinking on my feet right now, I'm gonna actually add that to our palette. And why is that? It's because when we write our tests, we will always have a value that we start in storage that we know will be in storage. So I'm gonna add that real quick. So this is, and so not all palettes will have this, but think of it as for a brand new palette that you would include in your runtime. Well, what do you populate that storage with, right? So this Genesis build helps build this the initial values of storage. So let's just go ahead and I'm going to copy paste it and fix it up. Okay, I personally like to put the Genesis stuff right after storage, and that's because for readability, just a preference. Genesis config, it's a macro that really helps. I think that, and also this has been changed recently, but let's see. I think this has been changed. Maybe note for next time. We'll go into like actual Genesis stuff, but dummy. Okay, this specifies the type in a Genesis, and then we need to build the storage. So this is just a the implementation of build Genesis config, and yeah, this is a good little piece here where so the build function, it puts the initial Genesis key values, or the key value pairs. This is also a little typo here. In storage. So and why? Because right now in our tests, I want to just easily say, okay, we expect that this value is going to be in storage, so it's going to be some balance, and then we're going to call this function that we just wrote, and make that call, and then we're going to check whether the value has been updated to what we expect, because we just have this simple mutate API, the storage value API with a mutate method to do that. My scratch pad. This is me multitasking. Notes. Note. Typo. Okay. back to this. So, oh yeah, okay, I'm gonna get rid of the other because we only have this one storage item, and I'm just not a fan of the other syntax. So I really like the syntax; it's much cleaner for me. Great. Let's just check if that compiles. The tests won't compile though. That's for sure. Yeah. Okay. This compiles. We just added this Genesis so that we can specify some. We're gonna in this mock environment. We're going to populate our storage. Woo! So much fun. We're having so much fun learning about this. Okay, I'm having fun like breaking down like some aha moments I had when I was learning this. Actually, at the Polkadot Blockchain Academy, we're just like going through kind of what we're doing. Okay. So we're putting 42 very simply. This runtime Genesis config, you'll see it in production chains that have specified this. This let's see the docs real quick. So look, Bridge Hub, this is a struct that contains the Genesis configuration of of a blockchain, of the blockchain, and in one of them, in one of these fields, we have some palette, and in our case, this is our super basic palette, where and this is a mock environment too, right? So we have there's some default for systems and for balances, and I think really this can be configured. I wonder what's in balances, but for our case, like I wonder what the default is for balances. I'm not entirely sure. Might be just 0. We have our example palette that contains dummy, and we're putting 42 there. Whew, that deserves just a little sip of iced tea here. Hey, cool. Yeah, I'm glad that's helping people follow along, even for those that are like advanced. It's actually really neat to see. So, one of the biggest challenges, by the way, like when you're kind of doing this, and especially from my perspective, just like an anecdote I want to share, is it's really easy if you're like kind of used to these code bases and used to like writing palettes to assume that there's so much like that oh we know what Genesis config is, or oh like macros, of course I know what a like I'm trying to really break it down so that anyone that's really coming and new to this code base can have a little easier time wrapping your mind around these things. Like when I learned Substrate and stuff, it was literally the node template is your starting point, run your blockchain, do the first tutorial, but uh, I had to do a lot of like going back to like these fundamentals, and hopefully this is what the series will be really about, um, helping people in that way, starting from fundamentals. Okay, so mock environment, great. Build storage, that should work. And now we're gonna just remove all the test stuff. I'm just gonna keep this execute with, because this execute with will use this Genesis storage. Look, it's a new test x dot execute with. So I'm gonna just keep it. Boom, boom, boom. You can check out all the tests for yourself that was previously in the in yield basic palette, which is not very basic. And okay, what we're gonna try to do now is actually test this. So we expect that when we call our accumulate dummy, that it actually accumulates. Simple. So I'm gonna just put this beside me to remind me of like the steps of what we're doing. Yeah. So accumulate dummy. Yeah, so we're gonna the first thing we're gonna do, and this is also just a little tip. I like to, when I write tests, like, okay, like, so we're gonna say accumulate dummy works. Right? That's literally testing this function. We expect it to. So the first thing we're gonna do is, just let's just check the genesis state. We put 42. Maybe let's just write a test for that. Try a test for genesis state. Check that 42 is actually the answer of the universe. Hey, let's check that 42 is the answer of the universe. Literally, like, check that it's in genesis state. So let's assert that we'll just borrow this. The syntax is like that, and then, damn it, and then we got that and that. Okay, great. Oh, damn you, sweet. Sorry, the swearing is just an artifact. Okay. Where are we now? Yes, we're gonna check that 42 is the answer of the universe. So is it the answer of the universe? Well, we want to just check. We're just gonna say assert. So we know we have, but in the Genesis storage of this mock runtime, the answer of the universe. So we want to just assert equal. It's a macro. We have this macro imported, by the way. Oh no, it's already part of the mix. Some of these asserts we need to import, but never mind. So what we can do now is just example dummy. And remember, like, and what's nice is like, this is just Rust. It's just very Rust. It's very rusty. What I mean by that is, okay, this might blow your mind. Remember, we have this very simple pallet struct. This macro does, I can't even tell you right now what it does without like going into the docs, and my point is not to do that, this attribute palette. But remember, it says this, the palette structs as a placeholder to implement traits, methods, and dispatchables in this palette. And okay, hold that thought. And now we've got, we put this one storage item that is also using another macro, this getter macro. It's a getter attribute on this palette macro, on this palette proc macro, called dummy. And that allows us to do something like let current value in dummy equals dummy. No, what am I doing? Equals out of the palette get. What is it? 1 second. That allows us to do. I'm blanking on the. Do. Yes. So, does anyone know what I was just like blanking on? Well, because it's this palette struct then allows you to invoke whatever function that is internal to this palette using self. So if I do that, current value in dummy self dummy, and that should return none, I guess, because there's nothing in there right now. And let's just okay. I go assert current value in dummy none. Is it gonna work? Yes, it works. And if I try to do 42, is that gonna work? Does that make sense? So we just like I'm showing that on this we can use this generated function dummy to go and get this value in storage. And we're doing this in the tests. What I just wanted to show you guys is when we do the syntax example dummy like that way, well, you are just literally because we have this example in our mock runtime that corresponds to the palette name, and we didn't go into this constructor runtime, but this constructor runtime does a lot of magic. There's like some research, like literally just look at the docs, but it's similar pattern, right? What I'm just trying to show, and that's what we're doing in the tests. So we're able to, yeah. And so what I did here is just to say like we can also call, we can also retrieve whatever values in storage there. We could. So this didn't compile because there's nothing in storage in the palette. This is the actual palette. Assert equal. But where was I going with this? Oh yeah, we could, we could do something like this. Like this is what the other thing shows. Let's comment this out. Okay, no, first let's write a test for this and then call it. But so yeah, boom, great. Yeah, hopefully that was something. Okay. Nope. What is this first test we're writing? Genesis storage works. Okay. What's in dummy? Well, 42, right? It should be 42 because 42 is the answer to the universe. And that should compile. If I had the REST analyzer, I could just press the thing, but let's see what happens if I run cargo test. App. Example, super basic. Let's see if we just, yeah, so that it'll avoid us to every time, right? Genesis storage works. And now while it's compiling, let's continue writing this. So accumulate dummy works. Oh, we have a little issue here, something. Let's see. Oh yeah, look, this is an interesting one. So it's saying that example does not have an event defined, which is true. Little detour. In our mock runtime up here, we're putting all the palette parts, and you can see that. So this is all like, I will say that like this is the mysterious part of Substrate, where luckily at Parity we really tried to be as like we're careful about writing macros that make things very obscure. But this construct runtime, if anything, that is like the exception to that rule, where this is like doing a bunch of stuff under the hood. But and essentially, we're passing in the palette parts: palette, call, storage, config, event. But because we don't have an event in our palette, we just remove that. We don't need that there. Let's get rid of it. And so that's what the compiler is telling us, that there's some issue there, because we're saying that there's an event, but it's not actually there. So let's try again. Okay, did that do anything? Oh, yes. I'm so happy that the compiler is telling us this because I wouldn't have thought about it otherwise. Okay. One thing that we've glossed over, and it's worth going into. And by the way, after this stream later on this week, hopefully there'll be a new PR that I'm working on that'll completely refactor this examples basic palette, and we like touch on it. But essentially, let's actually go back to what we can see in the generated. Okay, so the storage items of this is a little detour, but it's worth it. Yes. Okay. So dummy. This is how we like. We've declared it like this, like completely vanilla. Like I mean, there's not much going on, but there's like substrate storage AP, like the functional, the things that you can specify depending on what you want to do with a storage item is very flexible. There's a lot of things you could do, and by default, this storage value will expect that there is always some value, or sorry, that no, I'm getting tired, I guess. That the value will always be optional. That means in Rust, an option can either be a sum with value or none. And in this case, why is it freaking out? It's because in the tests, I didn't actually wrap this into sum. Hopefully that makes sense. Real quick recap is that I demonstrated it when I did a little detour here. Yeah, this is actually worth it again. Like I just did a quick, just like quick demo of none value in storage. This really just shows that at this point, our palette has nothing in storage. There is nothing in the state. No user has called this. There's no genesis that's been configured for this palette because we haven't built it yet. In the actual palette itself, in the mock runtime we have, right? But here, and so there's none. So we can expect none. And that's what I meant to demonstrate. And the compiler is complaining right now because it's saying, wait a sec, wait, like what? We like the storage thing that you've created should actually be an option value. So to fix that, I wrap it into sum. So something going on, compiler, what are we doing? Use of undeclared, oh yeah, I forgot to just, palette example, super basic. That should work. Sweet. Gulp. Hey, if anyone's joining us, I'll probably be wrapping up soon, but this is just for new people joining. It's just we're going through the like very simple patterns, honing in on one very specific thing that this examples palette provides as a demonstration of some feature in Frame, and that is manipulating one value in storage. So that's what we're doing. And in order to illustrate this, we're writing unit tests for it. Okay, boom. Oh yeah, so now judge the storage works. Accumulate. Okay, now let's actually write the test. It's substrate, right? It's like there's so much stuff. I've been going on and on about like everything other than writing the actual test. Okay, great. But hopefully we learned some stuff. Accumulate dummy works. So now what we want to check we want to check. What do we want to check? Oh yeah, our steps. Well, first we want to check that if a call is actually made with with a value. Remember, our call accumulate dummy takes two parameters, but the way that the frame macro works here is that really for the end user, this first parameter origin is kind of implied. You can think of it like that. So really the parameter we care about is that it takes this increase by parameter. So user will be saying, hey, I want to increase this value by some number. And this number is some type. It's a balance type that we put in before. So let's construct that. So this is where it becomes interesting. And we'll just go ahead and take and borrow some code from the tests from the examples palette that already exists. But what is interesting is that suddenly we're gonna be exposed to like how like calls are constructed. Okay. Yeah. Okay, boom. So I've just copied this over. Thank God for the jazz. By the way, I'm still listening to some. Oh, you can't. Yeah, you want to see? Someone want to see? It's really keeping me going here. Little man by the fire. Coffee, chill, music to keep you happy. Is it just me like that? I'm just scanning everything I see for typos. There's a typo there though. Yes, I like the lo-fi hip hop. Share your tunes if you're listening to anything. Okay. Check. One of my nitpicks is also that the comments should, if they're just like talking to you, they should not be full sentence. Like they're not capitalized. In my opinion, but that's what I change. So back to it. So we want to make a call. And let's just quickly scan through what this code is doing. Yeah, for default value. Yeah, cool. So in our mock runtime, essentially, the question becomes like, okay, but how do I abstract like accounts and balances and stuff like that? And essentially, we are like, let's go back to our mock config for the frame system config. So an account ID is just a U64 for the mock runtime. It's nothing else. Like, and that makes it really easy to write tests and to not worry too much about stuff that's just going to kind of get you too much in the weeds. Neat. So what we have here is we're just going to make the call, right? So example accumulate dummy. We're calling this function, and runtime origin. Remember, this takes two parameters. I did mention that under the hood, for the end user, it's really just one parameter if you're using this on chain, but we need a runtime origin type, which I'll always like 101 substrate or Polkadot SDK 101 use the Rust docs, and a runtime origin is actually defined inside this is where we go into like dark forest substrate world for those that are like completely new, so I won't go there, but essentially a origin can be actually defined at the runtime implementation of these pallets. High level, this pallet, any pallet in substrate is very generic. It doesn't really care or need to know about anything like account ID or the type of an account, what crypto it uses, or how this runtime origin type is defined. But it still has some concept that this generic type needs to be fulfilled. So it's signed and account 1. Great. Account 1 being, some accounts. And value 2. So we're going to increment this to, I don't know, like let, I don't know, something. Let val2, or why is it val2? Let incremented increment by 100. Let's do that. So let increment by 100, make this call, and then we expect that, oh yeah, because at Genesis, let's do that, let Genesis val 42. We know that already. We could have just written this inside of this test, but that's what we're doing for now. And then that should be the result of both, right? Phew. That's all this test is going to do. It's going to check that accumulate dummy works. We're also illustrating that this caller must be assigned origin, and that's how it would, and that's the only way that this could be called. Let's see if that compiles. Yes, so those tests work. So, I mean, let me just give you a, like, if I say increment by is some other number, that, like, we can expect that the tests don't break. And what's nice with Rust is that it actually shows you. It shows you what it expects. It says, hey, wait a second, I expected 142 that's in storage here, but actually no, it's 241 because this is, yeah. So that shows that. And what if we changed runtime origin to unsigned? Or is it root? Root? Sure. Oh yeah, it's not root. What was it? We have it in one of these tests here. Oh yeah, it's not like, duh. root doesn't actually take an account, because it's in the origins. Remember, we have signed, root, or unsigned, and if it's signed, by definition, you need to specify an account. If it's root, I would actually double check the docs on that. It's just the way that I'm thinking about it right now. It might be wrong. So I changed it to root, and what we can see really clearly now is that, well, that test failed because, well, it panicked, and it said bad origin. And bad origin is the error you'd get. And now back to our Rust docs. It is what this, it's a type in SP runtime that is an indication that an origin is invalid. So let's change that. Let's write one more test and then get out of here. And we're going to, let's go back into our super simple accumulate dummy. It's our super basic palette, right? It has just what we need. It doesn't have any configuration trait. It just has a storage item. And we've configured some Genesis for writing tests. Well, it's not for writing tests, but it was just a neat way for me to just show you guys something in addition. Accumulate dummy. Okay, so what if we wanted to write just one more function that can only be called by some root origin? Let's do that. So what we're going to do real quick is a function that can only be called by some root origin. So it's going to be a function that kills or deletes the storage value of dummy that can only be called by some root origin. Yeah, I'm just gonna format that. So, yeah, no, let me continue writing it. So we're in the call block of this really, really simple palette. There's nothing else going on but call and storage. And let's do pub. It's a publicly callable function so far as this block is. No, insofar as this palette sees it. And let's get rid of that. I'm going to say kill storage. Ooh, scary. Kill storage. Halloween is coming up. I don't know why my mind went there. Kill origin 4. Okay. And always return dispatch result. Dispatch result. Okay, this is where this function is going to be slightly different. Just to end for today, is that we're going to show that we're going to say let caller, so the function caller, ensure root origin, right? Like if anyone tries to call this function, an error will be thrown if they are not of origin root. That's what's going on there. Yeah, and so what is this going to do? This function is going to do? Well, it's going to take what's in dummy and and remove that storage. And thankfully we have. Let's go back to our Rust docs. So storage value. The storage value API has a function called kill, and it clears the storage value. So let's just use it. So let's say so our storage dummy kill, literally. And we could use another thing called put, I think. No, sorry, take. So they'll take the value and remove it afterwards. Maybe we can just showcase something with take later, like maybe not in this session right now, but what we're trying to show is that this is a publicly callable function that only some special origin can call. And we're also showing that we're manipulating this storage item dummy by saying, well, remove the value that's in that storage. And question for people that might be still following, I don't know, but what would you expect the resulting value once this is called? I'm just going to Rust format this. Another tip, cargo nightly format. Okay, like real quick, let's just finish writing this test, then we'll be out of here. I'm actually really hungry right now. I will probably go and find myself a sandwich. Boom, accumulate dummy works. We're gonna go ahead and really quickly do this. So kill dummy works. up, and we're going to construct a call, root call. We're going to ensure root. We're going to show that we have some value in storage already, right? That should be fine. And then we're going to kill it. And then what do we expect there to be? Let's just oh yeah, test. Oh. Associated function defined here. Oh, this is not the right function name. Kill storage or kill dummy, right? Let's call it kill dummy. And then we're gonna kill dummy, call kill dummy. Great, that should work. Not compile, blah, blah, blah. Oh yeah, we forgot to return anything here. So we're gonna return, okay, because remember dispatch result will expect the unit type or an error. We haven't gone into errors. Maybe that's something we can do next time. But this will compile. Yes. Okay. But this test didn't really test anything because all it says, oh, there's this in storage, and now we killed it. But now what do we expect in storage? So yeah, kill in. You got it. I'm trying to speed up here, but yeah, it's none. So we expect none. Let's double check that. Assert equal, not some, but none, because we've killed the storage. And what I'm showing here is that only some root origin can call this. So that would be like governance on chain. That would be like maybe another pallet that has access to call this function. It's really the system as a whole is able to call this function, not an end user. It's not a signed transaction in that sense. So cargo test. Thanks for that. Thanks for sticking around too. Oh, cool. Okay, that kind of wraps it up. I think we went through some really basic stuff, extracted. Notice, notice that we really just went through one of the things in this basic palette. Next time, I really hope that this basic palette will be completely refactored. There'll be better tests and it'll be easier to follow. But hopefully what we just did today is something that you can do at home too. Like you could create your own palette, go through the steps that we did. And nope, that's not what I meant to show. And, like really, really get used to the fact that the way that a lot of, just get used to like being in control of how you're using Frame and interacting with Substrate. I feel like oftentimes people copy paste things a lot and don't really think about the different underlying primitives and things that are happening under the hood. Another thing to note, just for those watching that might have missed this, is that we are using dev mode. So we're not talking about weights or anything. We're in dev mode anyways, right? Real quick, back to my Scratchpad and wrap things up. We do have a few questions that I'll follow up with. Maybe stay tuned on Polkadot Dev's Twitter, because this was fun and I got to learn too about things that would be particularly interesting for maybe you guys. So our Twitter is here, up Polka Devs, and we can show. Follow us on Twitter. We really try to engage as much as possible, and keep you up to date with as many interesting things. And yeah, hopefully we made Substrate less scary. I think there's one thing that I was requested to do that in my last breath I will do because I am a loyal colleague to my dear, dear colleagues who put a lot of effort into um, making Substrate more accessible too, in different ways. What I did was kind of diving into the Polkadot SDK, but um, oh, sorry, I'm losing my screen. Yeah, but there's this quiz that we do on Fridays. So every Friday, if you stay tuned, and spoiler alert, for those that have been here for the last little hour, that's kind of what I was going for, which is that there are some little nuggets that we found out during the stream, and we'll maybe use them to do some quiz. But this quiz here, real quick, what is the right answer to this, right? So I'll kind of explain the answer. It's Friday, and yeah, so every Friday we do a quiz. What is one of the roles that validators perform in Polkadot's network? What is one of the roles that validators perform on Polkadot's network? What do you guys think the answer is? Oop. So, yeah, anyone in the chat wants to quickly do this one? So, is it mining cryptocurrencies? Is it marketing? Is it maintaining consensus? Is it designing website? Well, spoiler alert, one of the roles that the validators perform in Polkadot's network is, well, maintaining consensus. And funnily enough, contrary to last quiz, a lot of people got this correct. I was gonna be like, I'm kind of brain dead now. I was gonna be like, funnily enough, there's 6.3% that think it's mining cryptocurrencies. Well, good for them. Hopefully those people learned something, and learned a little bit more about Polkadot. That was my commitment to my dear colleague. Thank you. Oh, I realized. Sorry, the screen is all over the place now. Yes, so it is maintaining consensus. Certainly not mining cryptocurrencies, not marketing, not designing websites. Stay tuned for the next quizzes, and yeah, I hope you guys had a great session. Next week we'll be continuing, right? So the SDK Unwind is an ongoing weekly stream, and I'm here to help people navigate and feel comfortable about diving into this large code base called the Polkadot SDK. Within it, we might drift off, right? We might go into other directions, such as looking at sort of things in parallel that could be interesting, like ways to interact with a pallet. So that's what I plan to do, and I also am excited that we might have some guests that I might bring in who work at Parity and who want to be sharing more advanced topics. So that the topics that could really cater to people understanding in-depth new features within Frame. What we went to today is very basic stuff, and I'm really excited to continue this stream with you guys. Thank you so much, and have a great rest of your week. We'll see you around. Cheers.